Welcome everyone. We're excited to have so many people here again, and just have a few reminders before we kick off into the actual session. How to jumpstart. So what we're doing today is really trying to engage all of you with us, with people who have knowledge and information, and our goal is to help that information exchange between each other and amongst and around, connecting the people and people to information. In order to do that, we need those of you in the audience to stretch a little and make sure that you are engaging. A few notes around that the audience does have to remain on mute during kind of the big keynote when we have a lot of folks on the call, but you are encouraged to use the chat. Please chat, please connect, use the annotations, use some of those abilities that Zoom has to engage. If you can, put your video on. We appreciate that. It's great to see live faces and a live audience. It just allows the presenter to play off of real people. If you can't, because of bandwidth or other reasons that you don't want your video showed, some type of photo, or even if you don't have a photo, maybe it's a picture of your cat. Anything that represents who you are and what you stand for would be really great. If you have a team, maybe you want a team photo up, whatever you'd like to do, but something that makes our Zoom calls just a little more interesting. At the end of the keynote, we will have a more moderated Q&A, although continue to have those questions come in throughout. That's wonderful. And the team there will be capturing and curating those questions. During the learning sessions, though, please make sure you're muted. Make sure at any time that you're not talking, it's good if you're muted. Again, ask those questions in chat. Use the open mic. If the presenter says, please use open mic, do use open mic, unmute for those Q&A. It is much more engaging to actually have conversation than to have everything happen in the chat. Again, and if you have something in the chat, we are recording these sessions, so make sure that you repeat a question that might be in chat, repeat that out loud so it's captured on the recording. And again, share a photo, use your video as much as possible. All the sessions that we're doing for all 3 sessions of JUMPSTART by Medtronic will be available on the new site that's evolving called jumpstartrobotics.org. So we're excited about that. Again, all these calls will be recorded for training purposes, and everything will be captured and shared potentially outside of this event. With that, we certainly want to thank our team of sponsors. So the Central Minnesota Robotics Hub is where a lot of, all of JUMPSTART began. So the teams that are part of that, we have sincere appreciation. And then again, for those sponsors who are carrying that forward. A reminder, last time I went through these, this is about what we have for stats. I think a few more teams have now registered since the October stats were captured, but know that that is what this session, what JUMPSTART by Medtronic is about, is pulling together all of this information and those folks together. Reminder of gracious professionalism. I won't go into all the details. I shared this on October 13th at that session, but make sure we're treating each other with respect. Woody Flowers would appreciate it. We're all here for the first organization in that honor, and we want to continue to respect those presenters, using the Zoom appropriately, the volunteers, respect each other, and of course have fun. That's what this is all about, having fun with science and technology. With that, Delta ModTech is the sponsor or the host of this session. They are a manufacturing solutions company with over 40 years of mechanical, electrical, and software engineering experience, designing and building specialty web converting, packaging, machinery, all kinds of equipment and automation. They are a global company with offices around the world. And today we are really delighted to have Todd Cruz give us a live in-person tour of some of the automation lines, streaming with a live stream through their Ramsey facility. Many of you know Todd. You see him there in his full orange hat gear as a first judge, and he's obviously at a lot of competitions and such. Today we get to see him in the work that he does in his day job, and actually have a photo there of him in his day job. And with that, without further ado, Todd and Wendy, take it away at Delta ModTech.
Well, good morning, everybody at FRC community. Thank you, Shar and Medtronic, for graciously hosting this again. We enjoy our partnership here. Yes, like Shar said, we are live at Delta ModTech. We are in Ramsey, Minnesota, our new facility here, and we're so excited to have a few students here live with us. We have 768 few members here, and we have new legacy 8516, one member here checking it out as well. And also we have 4607 going to be doing their live presentations from one of our conference rooms isolated up there. So again, thank you for joining us today. We're excited. We're going to go through a bunch of stuff here and what Delta is, and talk about some things that we're hoping is outside of the box here, because Delta, we do capital equipment building and stuff, and I won't take the thunder away from Wendy. Wendy's going to be taking it off there. But with that, Wendy, are you ready to take over? And Wendy is our owner here at Delta, and I'll let her explain.
Hi, everybody. My name is Wendy Stromberg. I just want to make sure that my screen is up. Everybody see that okay? Okay, great. There we go. Okay, so this is our new building in Ramsey. We were very blessed, excited to build that this summer in the middle of COVID, which always adds an interesting twist on things. But we are located here in Ramsey, Minnesota. We also have facilities in Pennsylvania where we do our coding research and development. We have facilities in Sweden as well. We are known for developing some of the first servo-driven converting machines, and I'll talk about that a little bit later, what that means. We've been in business for 41 years, and we have over 1,700 installations worldwide. So that's full machines. Those are large systems that we currently that are currently running. We have over 160 employees, and 80% of our staff is engineering or technical based. These are some of the products. Now, bear in mind that because of the business that we're in, we're not able to disclose some of our customers' most confidential parts. But these are parts that you could find at your local Walmart and things like that. So that's why we were able to display these. But we design machines for the medical, pharmaceutical, packaging industry, electronic industry, automotive industry, and personal goods, printing and labels. Some of the new emerging industries that have been really fun to be a part of are the fuel cell batteries, as well as some of the medical test strips. We've been involved in medical test strips for a while, pregnancy, blood glucose, and flu. But you can imagine with new pandemics, those experiences expand. But I'm not here just to tell you today about, sorry, I don't have a good picture of myself, about Delta. I thought it was interesting to share a little bit of my story. When I was going through engineering school, I knew from a very young age. I was 7th grade when I decided I'm going to be that engineer. It was first aerospace based and then biomedical. But unlike you guys, I just did not have a platform or a vehicle to see if my dream was a reality. And so I sought out mentors, I sought out different people that I could shadow, and really kind of walked in faith that engineering was the right road. I knew I loved math. I knew I loved solving problems. But I just didn't have a vehicle like your robotics teams to flesh that all out and figure out where my strengths were. I was fortunate enough to find a group of engineering students, and we bonded together, made it through school. School was hard. It was not easy. I wasn't one of those that floated through. But after interning here at Delta for 4 years, I started on as a full mechanical engineer in 1995. Now, oddly enough, you would think I found my fit, and that was not the case. I was 2 or 3 years into the design process, realizing I'm not sure I made the right decision. It was actually a customer of ours. I was designing a custom machine for him to index plates into a CNC mill. And he said, you know, you seem to have a really big picture view of things, and you're able to understand concepts and communicate that. Have you ever thought about sales in engineering? That really launched a career for me. I spent the next 12 years in sales, loving that opportunity, because it's really a go-between position, understanding a customer's needs, communicating that back to my design team, and then coming up with a solution that we again communicate back to the customer. So really found a niche and a fit there. But as a female, I had another challenge. I was also feeling called to raise a family, and travel was not conducive to that. So I was able to shift into a marketing role, which again, so thankful for the mechanical engineering background because I could speak to the technical as well as to the customer's needs that I work with. You know, and now as a second generation business owner, I am so thankful for all of those hats. And bringing this right back around to where you guys are at FIRST, that is what encouraged me so much about the whole FIRST program. I want to get to a slide here. My team, Todd invited my family, my two boys in the front, to your first Minnesota event in 2018. We were blown away. Not only are you guys great innovators and lots of ingenuity, but you were great hosts as well. These three guys that led us were so courteous and helpful and kind. We were just blown away. I mean, these are the type of people that every corporation wants to hire, right? Mm-hmm. Good job, teams. These are great. But not only did I see these three individuals, I looked around to see the micro businesses that you guys are creating. Everything I just described, you need engineers, you need the sales, you need the marketing, and you're all part of that team. Researching, designing, and manufacturing solutions. It's impressive. So here at Delta, we strive for a very similar servant-based culture. I have to tell you, Shar, I was really, you know, when I listened to Mike Hess's and Dean Kamen's speeches last week, I couldn't believe what a similar platform that we work on. They described the process of innovation. Good design and great innovation, they said, is always a response to problems. Now, I don't know how many of you have ever dealt with a problem. A lot of people look at problems and say, oh, but a good innovator says, there's a problem, I get to solve it. And actually take a seemingly impossible road. That's what you guys get to do in these innovation careers. And that is really, by the way, the backbone behind my dad's story. I just want to share with you a little bit about how Delta was started because it fits square with what Dean and Mike described. My dad, in 1979, was building and designing machines. And he was doing a one-off approach to every machine. He was innovative. He put servo motors on each of these machines, on each station. But he still, not only was he meeting the customer's problem, but he realized he had his own internal problem, and that was this. It's really, really hard and costly to build custom machinery that doesn't have some semblance of modularity to it. So in the 1980s, he set on a quest to develop ModTech, modular technology. So what Todd's going to go into detail on these modules, but bottom line, what that did for our company was massive. It allowed our mechanical and our electrical engineers to prove their designs and then use those proven modules to build custom machines for our customers. Here's a little quick animation of how that works. It's really like a great big erector set, isn't it? Putting in the proven pieces that we need to make a custom solution. Machines range from this very basic machine on the left side to very advanced. And quite frankly, the size of the machine has grown far beyond what this picture is. Full lines. Now, if you could get in the inside of these machines, you would see robotic lines on this end where my mouse is pointing to. You've got several vision systems inspecting and looking at parts through this system. One other thing, before I hand it over to Todd, one other thing that really stood out to me from Dean Kamen's speech, and I wanted to capitalize on it. He talked about failure. And I'll tell you what, if there is anything that I have learned from my dad through the process of watching him in business and innovation, that is, you really have to embrace failure. On On the end of your customer, just as Dean explained, failure is not an option. We're not going to fail on our customer's behalf. But inside of the design process, it is so helpful to run a parallel path when you're designing. And you're going to find this in your teams this next year. Run those parallel paths. Take a risk on some of these things because it's the only way that you will get to market quickest with your product and your solution. And I just really thought Dean did a great job hitting that out of the ballpark. Todd, can we turn back to you in the machine? Maybe?
Yep, we are running. There we are. We here? All right. Thank you, Wendy. Thanks for the introduction to Delta ModTech, and thanks for all the great years. I've been working here 20 years now, so it's been a long time I've been here. And today we're going to be going through the machine design. So I'm going to bring in our coworker, which is also a mentor as well to a first team. So just to recap again, I'm Todd Cruz. I'm a Delta electrical engineer here. I've been working here 20 years. And in my spare time, I mentor students in FRC. I started with 3048, originally TNT on my son's team. And I wasn't very involved the first year. And then the second year, he got me hooked, and I've been in here ever since. So with that, we're going to introduce Chris Haugen. He's going to go through some of the machine design. We're going to tag team as we go through it. So Chris, want to introduce yourself?
Sure. Hi, everybody. Yeah, like Todd said, I'm Chris Haugen. I've been at Delta not as long as him. I'm kind of more in that 8-year range. I'm a mechanical / design application engineer here at Delta ModTech. I am and have been for several years now a mentor of Team 2508 Stillwater Armada. I was also a part of that team for my single year as a student within FIRST. That was for Lunacy year back in 2009. So it's been a few years since then, but once I had the opportunity and stability to be able to donate my time back again, I've been helping out my old team. So in Stronghold year, I was able to have enough time to head back out there and help out, and it's been a great experience doing it ever since then. And thanks to Delta for kicking in and helping out with that and being understanding and supportive of both Todd and myself, helping out younger generations and teaching them some cool stuff. So it sounds like we want to walk through this machine here.
Let's start with the spindles and that.
So this particular machine is kind of a sample of like a medical product where it's actually unwound off of a spindle, a roll of material on the front side. It comes into these stations, into these modules. It gets brought in, controlled, slit into 3 lanes from a single. Then those 3 lanes are spread apart and brought back down to the main product stream, where then they're sheet off at the correct lengths. This die, so you can see little short sections here, they're being sheet off. And this material down here is actually the pouch material. So it's being cut directly onto that pouch material. And then after that's placed, we bring in a clear layer of pouch material on top to complete that.
So let's interject a little bit here, Chris, on here. On our machines, everything is, since it's servo driven, can switch directions at any time. So we can go forward, we can reverse on here, and that's all through our HMI control on here. So in the spindles, it doesn't matter if the material comes wound in clockwise or counterclockwise. We've been able to put it on the machine, change the direction where we need to do on there. Same with each one of these servo nips on here. We have nips on here, or we have like a sheeter die on here that can cut the product, but all these are reversible. You can go forward, you can go reverse on there, just like switching on it. It's kind of like driving your robot now. You can get your joystick on here, but instead of a joystick, we have to program using our HMI on here. One thing I also want to point on here is there's vision tracking on a lot of robots. On here, we've been using Cognex cameras for a lot of our vision systems here. We use these a lot on tight tolerance or critical dimensions that we want to do online processing with. And so what this camera would do is take the width of this material and we can feed back to the system to tell us how well we're slitting that material. Or we could take it over here on the pouch stock here, and when the part comes in here, we can look at it and we can do the dimensions of this part here. There's just a little rectangle here. Most time it's very complex parts we run on these machines, but we can do dimensions on here and we can feed back to the die station here and say, hey, you're too long, you're too short. And we can auto correct the machine for that. So kind of like your vision tracking in your robots, you'll be able to track into a target. Here, we're going to track in a target of what's going to make the customer specifications by using the vision on here. What else we got in here, Chris? So we have the different materials on here as we can jog and bring it towards the packager side of it. So if there's any questions in the chat or you want to zoom in on something, let us know. We can zoom in. We're kind of going to go through the different components on this machine. This is only one type of machine we do here at Delta called the converter packager.
Points, Todd. Yeah, from there we now have our package material, part package material sandwich that we're bringing into our reciprocating heated seal bed. So that seal bed is moving to the correct spot to come down and close, stay closed for the correct duration of time with the correct temperature and pressure to create the optimal seal qualities in the pouch that we're looking for before it then opens up once that seal is completed and travels back to the next set of seals.
So guys, it looks like our parts are not in register. I can see that in the camera, but typically that's a really big design input that we have to address. What type of tolerances do you typically want to be holding on this type of medical product?
It's a little bit of a tough question because it definitely carries from one product to the next. In this case, what we're really trying to just make sure is that the part is actually in that pouch. So if Todd grabs the pouches from down there.
Right now, what Wendy's saying is this blue part here is not in the seal window. It's actually on the top. So that would be a reject. We would reject it off the line at that point. So our goal and the target when we're cutting it off the sheeter die and placing it on here, we have sensor feedback that we're continually feeding back into the system to hold this part in the center of the seal. You can see there's a chevron type of seal on here. And usually it's not a big problem because you can see the inside part relative to the pouch stock is quite a big difference, right? There's a lot of room that this part can move around, side to side, cross web we call it, or up and down web, which would be the lengthwise of the pouch here on here. So what we have to do is, as operators and setting these up, is we'll have to go in and adjust the registration on the screen manually. So as you can see on here, and give you a little more information about how the registration works on here, is see this die here, and I don't know if you got it zoomed in pretty good. Right here's a cam on here, and so there's a sensor on here, feedback. So on robots, my students know this quite well, and when you want to do a manipulator actuator and that, what's the first thing we do? Come on, Nate, back there. We home it, right? We have to home it, we have to reference it. So once we home that, we'll get to do the calculation, and we can know exactly what this die is, how many round it is when we put a pre-programmed part length to kind of get us close, right? So it references that. Now, from that, we can feed in sensors to reference the die here to move it up and down web. Can't do a cross web because this die is only going to run in one direction, right? So let's think about that. So if we wanted to move it in cross web, how would we do that, Chris? If I was off in the cross web, how would I do that? Just that.
Either you could actuate the whole station in and out if it was cutting out the whole die. In this case, it's only sheeting out the front or back, right? So you really can't change the width using this tool. So you'd come back here and you look at the slitter die, which is slitting it again and from that single lane to several lanes. and we may adjust these blades, the location of those blades, or adjust the guide rings that are guiding the material to their final locations.
Perfect. So as we come down the line, then we can do our adjustments. We can have vision feedback on there if we would desire on there. We got the slitting knives. So when we're running process, a lot of things can happen, just like in our robots, right? Things break, things take down. Typically our deltas don't break, inside joke. But we are very robust on the what we do with our setup on our die stations and everything, and how we move it through the nips and stuff. It's nip pressures. We have a lot of knobs on here to adjust things. Like Chris mentioned, there's a cross on here. You can dial the station in and out, especially if you had an engraved die station, right? So this is a sheeter blade. What's the difference between a sheeter blade and an engraved die setup, Chris?
The sheeter is just a straight one blade where it's cutting it off to length, versus an engraved, you're cutting the full geometry of maybe a circle, right? Cutting that whole circular shape. So if you want to adjust that in the crossweb direction, changing this knob, moving that station in and out with that die in it makes those adjustments.
Right. So if we come back down the rest of the machine here, we have what's called the packaging side of it with the heat seal. So these two plates are here are heated up to a temperature, and it has this engraved bossing on here, engraved into the plate. And so Chris can explain it better than I can, because I'm an electrical engineer, but there's a machined out plate that has the chevron on here and this impression. And so what we use is we use temperature and air pressure on them plates as it comes down. And it squeeze it, and what it does is what we call it likes to hitch on, and then it goes, rides with it. So if I jog a little bit, you'll see what I mean. It comes back, it closes, and then it rides with it. So we're matching speed. So anytime we're doing robotics, when one of our drivetrain wheels are slipping in that, what happens to the robot? It drives sideways or crooked or turns all the time, right? Here we have to do what's called a programmable cam on here that will go back in timing with registration, because there's eye marks on here. Does anyone know what these eye marks are on the pouch stock you see all the time? When you get these type of packaging from, does anyone know what that eye mark is? You think this is part of the graphics? Anyone know what that's used for? So being in this industry so long, I always look at the eye marks now, because you know why? Because that's usually an indicator how well the machine is run. That's our registration mark. Either we'll have it offset, or a lot of times we will cut that and break that eye mark. So in robotics, what we use that for? Sensoring, for sensing distance or a certain move on the mechanical setup of your actuators, manipulators, whatever you have on there. We would use a sensor to move it to a location. Same thing in what we do here at Delta. We're moving it to a location. So on the steel bit here, and then down here we have sheeter knives that will sheet the part off, and then we have what's called slitter knives down here as well. And these are all air driven up and down that will trim it off. Sometimes we trim off the edge of the pouch stock and vacuum it all the way, or rewind it, and then it will slit in individual lanes. And you can see this is not cut quite right, and then usually a part gets jammed in there. Down here, then we just have a simple ring nut that goes between the seal regions on here. And then just like we have down there, we have a basic sheeter knife that we can put in and program different sizes on there.
So Todd, I know that you're kind of running out of time here.
Yeah.
There's a couple of really great questions in the chat. If I can just shoot those out quick, and then I know you also want to get to your last interview. First of all, how much does a machine like this cost? That's a really great question, and there's no right answer. A machine of this size can be anywhere from 400,000 to million 200. We do a lot of custom programming on behalf of our customers, and so the HMI that you see behind Todd, he can put anywhere from 1,000 hours to 5,000 hours in customizing the software to give that customer exactly what they want for data. So great question. How many unique components are in a machine this size? Another really great question. We purchase the components when we can, but boy, a lot of what you see, I would guess 95% of what you see is custom designed and manufactured by Delta and our partners. So number of parts, I don't know that I could shoot you number. Todd, do you have any ideas?
I have no idea. We do parts from all different ranges out here.
Yeah.
Yeah. And last question that I'll ask is, what is the maximum throughput of a machine like this? And again, so I'll let Todd kind of answer that, but it really is dependent on the customer's product and the quality verification that they're trying to achieve.
Right. Yeah, and this flat steel bed's designed for 100 feet a minute, right, Chris?
Somewhere around that. Yeah.
Right.
I mean, it all depends on, how long does it need to stay closed
Right.
and with the material. If I put in a 10-second dwell time, it's going to get slower than if I can do it in a quarter of a second.
So what happens in there and the software, we won't go into a lot of detail, but if you put a longer dwell time, which means how long it stay closed, because it could come up before it reaches the end of travel, we will automatically open it up and return it. So then it won't be sealed well. But we also have flags in there to tell you speed limiting. It won't let you do that as well because it takes a while to train operators and all these little settings in here. But it all depends on the part size, really. I mean, it's a hard question for us to answer because if you have a bigger part blank, you can do a lot more parts. You do smaller ones and you got them bunched together, it changes the thing. Our converters, our base machine can run up to 300 feet a minute right off the floor. We've done faster machines, but that's what they're designed to do. So we're running out of time, which is unfortunate because we like to keep going with this on here. So the last thing we wanted to do was bring Eric Maloney in. He's alumni. Where's Eric? Eric, come over here.
Hello, Todd.
Hello, Eric. Eric, why don't you tell us a little bit about yourself here? We first met as the rookie team of 7068, and now we're at today.
Sure. So my name is Eric Maroney. I graduated in 2018 from St. Francis High School, Team 7068. I am currently attending the University of St. Thomas for mechanical engineering, and I'm a junior.
So just ask about your experience here as being an intern and what FIRST has done to help you with that.
Sure. So FIRST Robotics has been very beneficial for many aspects. You get a lot of team building skills, a lot of engineering skills, a lot of troubleshooting techniques I learned. But another really important thing about FIRST is the connections that you make. For example, I met Todd, and thanks to that, I have a wonderful internship. So yeah, it's definitely an awesome experience.
Yeah, we're excited to have you here at Delta. You're a junior now, and so in a couple years here, you'll be graduated from Delta, and I'm sure the door's gonna be open here for you to work here full time. And so we enjoyed it, and it's fun for me as a mentor to see this type of growth. You see him as a student, and they're what they contribute to building the robot, and now what he's doing in the workforce. And this is what this demo is all about. We want to bring industry a little bit different, and instead of just giving you sessions about robotics and controls and marketing stuff and SWOT analysis and that, all that stuff plays a role in what we do here at Delta. And so we're super excited again that we were able to do this here. Can't thank Wendy and the leadership team here at Delta for letting us come in today. And